Alright, so you guys see we had a little bit of issue with this problem, and I'm gonna make it really easy. And there is a lot of things, inside it, as you guys would see. If you learn those, then things will get easier, yeah? So we got this manufacturing plant, but this is what the question is saying, guys, yeah? We got this manufacturing plant, and the voltage phase to phase is how much? It is 2400, yeah? 2400 volts right here. The power that is going into the plant is how much? 415 kVA. Yep. And the power factor is given in the problem, that is equal to 87.5. Yes? The question is saying find the Z of the plant, phase angle, and find the phasor diagram. Okay? So now, the only issue that you guys would encounter is finding the current, and I want to make sure that you guys get it. But here it doesn't say that the internal, is it Y or is it delta? It's not given in the question, yeah? So if it is not given in the question, what we do? We automatically consider that it is a Y system, yeah? Make sense? So draw it like this. Phase to phase voltage is how much? That is 2400. It is 2400. Let's quickly find out what is phase to neutral, yeah? So to find phase to neutral, this is how you do it. Voltage, phase to neutral equal to, of course, this is Y system, and Y system, the voltage, phase to phase, yeah? Sometimes you guys will hear a system voltage, phase to phase, and phase to neutral is not going to be the same. However, the current is going to be the same, what is what is from phase to phase and phase to neutral, okay? So how do we find it? We say 2400 divided by under root 3, and Mike, tell me what is that?
1385.
1385.64. That is this voltage right here, 1385.64. Okay, phase to neutral. Very good. So then we are finding what? We are finding the current. Okay, that's now easy. Current equal to what? Ohm's law, very easy. We got power, yeah? So we got power is how much? 415 kVA, yeah? It's hard to do this regarding in lab. You guys know there is too much noise. We got all kind of pumps and things running. But let's focus here. So we got power, very simple. Power equal to current times voltage. And we are interested in current. Okay, so the current equal to power divided by voltage. Very easy. See the way the numerical or the problem is given in the book, it looks very hard, but it is simple algebra, yeah? So the power is how much? It is 415 kVA, yeah? And that is kV in 1000, you guys know that. Divided by, what was the voltage? 1385, isn't it? 0.64. So do on your calculator what you get. 299.5. Awesome. So that is the current, okay, which is flowing here and which is flowing here, isn't it? Of course it is, because that is a Y system, yeah? Current stays the same. Now, so to find Z, again, Ohm's law, what does the Ohm's law say? V equal to I times Z, isn't it? This implies that Z equal to what? V divided by I. Very easy. What is V? Isn't it 1385, my dear friends? Yeah? 0.64, and divide that, the current is 299.5. What do you guys get?
4.63.
4.63? 4.63 ohms, yeah? Sounds good? So that's our Z. So I hope you guys are seeing this, yeah?
Yep.
Alright, let me move on. What is the next thing we are finding?
Phase angle.
Phase angle, okay. I want to talk about a little bit about the phase angle. Okay. So let's see, phase angle. The power factor is given how much? The power factor, my dear friend, is 87.5. Yeah? Sounds good? You see, what is this power factor? You guys know it, but let me quickly show it you. Remember these things, okay? That if we have power, power is made up of what? It is made up of reactive power, power reactive. Okay? And it is made up of power active, isn't it, guys? And what is it telling me? It is telling me from American Electric Power, when we receive this power, yeah, the power factor is telling me this. How much of the power which is coming from American Electric Power, yeah, from the generating station, how much of it is turned into useful work, yeah? So there is multiple ways to represent this power factor. We can represent it through resistance, we can represent it through power. Okay, so now remember, along with that, remember this too, that if the power has two components, one is reactive, one is active, and everybody give this example, isn't it? Like you have Pepsi, and this is the Pepsi, when you drink it, it goes in, yeah? But then on the top, what you guys have? You got the foam, yeah? And without the foam, what you tell them, hey, man, there is no foam on it, it is flat, I don't like that Pepsi, yeah? So this guy right here is the active power, P active, this is the reactive power, yeah? Without this, no enjoyment, you have to have that, yeah? Plus what it does is, in the transformer and then in the other electrical machine, in the rotating machine, the transfer of energy without this is not possible, yeah? Because that is the one which is create the magnetic field, and that in that magnetic field, then the active power transfer due to that, and the energy power transfer. So in an easy example, I will just give you another example too, so it is, you guys can see it. So if you have a motor, yeah, and let's say this motor is connected to what? To a conveyor system. So when this motor rotates, this conveyor system go forward, yeah. There is other, let's say mechanical drives and stuff which translate the rotational motion into linear motion, yeah. So the actual work that is done right here, that is your active power, yeah. But internally, inside this motor, we have produced a magnetic field, and that magnetic field is then, rotating the rotor, yeah? Does it make sense? So what I'm saying is, power reactive, power active, yeah? So what we are saying that this power factor is how much of this active power we are getting from what? From the power which is coming from your generating station, which is power apparent. Make sense? Now, let's go on. Similarly, power has, this apparent power which is coming from AEP has two components, yeah? Similarly, the current has two components. What is that? I active, I reactive, I active. Okay, similarly, the voltage, okay, is V reactive and V active. Just I want you guys to remember for further classes when we are talking about transmission and distribution, okay? So this is a very simple course, the electrical machine. As we go, it will get a little harder. So you guys see that's what, so let me make it more very easy, okay? So say phase, Z of the plant, we did that, and phase angle, yeah? Guys, what do we got? We said that the power factor is what? The power factor is cos theta is equal to cos theta, yeah? Yeah, no? Yeah. And what is cos theta? Cos theta is, this is power active. And what is this? This is apparent power, power apparent. So cos theta would be equal to P active divided by P apparent. Alright, that's good, yeah? But that is given, that is how much? 0.8. So we will take it in a percentage, that would be 0.875, isn't it? 0.875, my dear friends. So to find this angle, how do we do that? So theta equal to, we take this guy to the other side, this is plus 1 here. If it goes to the other side, so this would be cos inverse of 0.875. What do you guys get? 28.9. So let's say 29 degrees. 29 degrees. That is the angle between what? Guys, that's the angle between what?
The active power and the apparent power.
are the voltage and current, isn't it?
Yeah.
It's the angle between. This is a lagging power factor, okay? And lagging means that the current is lagging behind the voltage. Yes, guys. So if we look at it, so let's say we got this guy. So this is voltage, yeah. This is voltage, and right here is the voltage. Sounds good? So this is, let's say, VAN, VC, okay, and with this guy, this would be VBN, isn't it? It is, yeah? Make sure. Can you verify, Mike? You don't have it. Sound good? So we got VA to neutral, VB to neutral, and VC to neutral, yeah? And what we are saying, guys, it should not be hard. This told me what? Well, that is too big. Let me make it smaller. So that is right here. This guy right here is how much? It is 29 degrees, isn't it? We say 28.8. So the current right here, which is IA, is lagging behind the voltage is 29 degrees, yeah? See the angle between right here, this phasor is what? It's 120 degrees, they are separated, yeah? So if this is IA, he is lagging behind what? VAN, yes? The voltage to neutral, see this we have drawn this vector, that's that guy. We are saying I line, that's the current coming from base to base, yeah? So then make it right here, 29 to, this will be IC, yes? Make it smaller, whatever this size is. This is IA, and this is IC, that will be 29 degrees. We are going counterclockwise, okay? Make sense? And then, of course, the other one will be right here, yeah? 29, sorry, no. So, 29 degrees, right here. So this is ID, 29 degrees. Are you guys getting it, the phasor diagram? Yeah? So this guy is lagging behind the voltage, the IA, 29 degrees. And the VCN, so this is the IC is lagging behind VCN and the IB is lagging behind VBN. Are you guys getting it? So that's it. If you guys have any questions, let me know.